button so that each time new videos is being uploaded, you can have the opportunity to watch. And also tell your friends who are in secondary school and tertiary institution, they will have an amazing time on this channel. I'm telling you, physics, chemistry, and mathematics, of course, further mathematics. So for this time, we shall be looking, I'll be looking at chemical equilibrium. Chemical equilibrium. Chemical equilibrium. Obviously, we know that the word equilibrium has to do with a kind of balance, either balance system. Okay, in the economy world, you say that equilibrium means a situation where demand and supply are equal. But we're not talking about equilibrium here. When you talk about physics, the definition of equilibrium is quite different from the definition of equilibrium in chemistry. What then is the definition of equilibrium in chemistry? The definition of equilibrium in chemistry is a state where there are no observable changes in the property of the system. That's what we call equilibrium in chemistry. A state where there are no observable changes in the property of that system. We call that equilibrium. And obviously we have the two types of equilibrium in chemistry. That's static equilibrium. We have static equilibrium and we have dynamic equilibrium. For static equilibrium, that's the one at rest, from the word static, at rest. While dynamic equilibrium is the one at motion. And since we're considering chemical equilibrium happens to be a dynamic equilibrium. Chemical equilibrium happens to be a dynamic equilibrium. Okay, at what condition does chemical equilibrium can be established? That's a beautiful question you need to ask. At what condition? There are various conditions, but let's consider 4 or 5 of those conditions. Number one, the rate of forward reaction must be equal to the backward reaction. So you have something like this. C and D. The rate of forward reaction must be equal to backward reaction. Number 2, the reaction must be a reversible reaction. If the reaction is not a reversible reaction, you can't be talking about equilibrium. It has to be a reversible reaction. No matter how little the reversibility, but it must be a reversible reaction. So the reaction must be a reversible reaction. Must be a reversible reaction. Number 3, it must be a closed system. The system must be a closed system. It must be a closed system. What's a closed system? A closed system is a system in which energy cannot be exchanged. That's a closed system. You have something like the calcium trioxocarbonate form, and then calcium oxide, which you know as quicklime, this limestone, and then you have carbon dioxide. A closed system. In a closed system, this gas here called carbon dioxide, or what is also called carbon dioxide, cannot escape. Okay? At number 4, that gives energy, what you call the free energy, that gives energy must be 0. Gives energy must be 0. Gives energy must be 0. So the gives energy must be 0. And then when gives energy is 0, we say that that is equilibrium. Now we know that when change in gives energy is negative, We call that a spontaneous reaction. That is a reaction that don't need to be triggered. It occurs on its own. And then when Gibbs energy is positive, that's non-spontaneous reaction. And then when Gibbs energy is equals to 0, that's what we call equilibrium reaction. That's equilibrium reaction. So you have the non-spontaneous reaction, you have spontaneous reaction, and you have equilibrium reaction. Now don't forget that I'm trying to establish condition for chemical equilibrium. Number one, I made mention of forward being equal to backward. I made mention of the reaction of a system must be reversible. I also made mention that it must be a closed system. And then I also said that the Gibbs energy must be 0. Not only that, number 5, the change in concentration, of the species in equilibrium with respect to time, must be 0. The change of concentration of the species in equilibrium with respect to time must be 0. That is dc dt. For those who understand calculus, dc dt must be equals to the 0. dc dt must be equals to 0. So those are the conditions for chemical equilibrium. Now we have what we call equilibrium constants. Now equilibrium constants, we have equilibrium concentration, equilibrium of partial pressure. Okay, now chemical equilibrium constants can be expressed this way. Using something like this, we have a situation like this. How do I express equilibrium constants in this way? It can be expressed this way. We have C, and then you have it this way. You have D. This is A. Now it should be noted that what you have here is not just a bracket, it's concentration. And concentration is given in mole per dm cube. Example, let's look at the Haber process of ammonia. Considering the Haber process of ammonia. So here you have Haber process. We have Haber process. So here, okay, this is Haber process ammonia. Preparation of ammonia. And look at this reaction. If we are to write the equilibrium of reaction or equilibrium of partial fraction, which of them, whichever one we are expressing now, to write the equilibrium for this is going to be NH3 raised to power 2. Going by what I have there, you have N, and then we have hydrogen, we have 3 here. Now, if I want to find the mole per dm cube for this reaction, I'm going to do it this way. So this is mole per dm cube. Then you have squared outside, and then this is mole per dm cube, and then this is mole per dm cube. You have 3. From here, this will give you mole squared. This will give you D6. This will give you mole raised to power 4. This will give you mole 12. Out. This is minus 3. Minus 3 times 3, that's minus 9. From law of indices, it becomes minus 12. When you apply your law of indices properly, you have this 2, you have this 4. Taking it all, you have the mole minus 2. Taking this all, minus 12. Minus 6 minus 12. That's minus 6 plus 12. And that will give you dm cube 6. That's what you're going to have right there. And that is the expression. And now we need to consider what we call Le Chatelain principle. We need to consider Le Chatelain principle. What's Le Chatelain principle? Of course, Le Chatelain was a French chemist, and he defined the principle as if an external constraint, such as change in concentration, change in pressure, and temperature, is imposed on the reaction in equilibrium, the equilibrium will adjust. Why? So as to annul, so as to neutralize the effect of those external constraints. Of course, that's normal in life. That's not normal in life. That if there's going to be a pressure being mounted on an individual, the person will have to find a way so that a system does not get damaged. The system will want to be in equilibrium, so something will have to be done. And the same thing in chemistry. So the system will adjust, and the essence is to annul or neutralize the effect of the external constraint. So we look at the three factors that the Chatelain said. It said change in temperature, change in concentration, and change in pressure. Now, the three factors will be considered very closely now. Number one, he made mention of change in concentration. Let me start with concentration. How does concentration affect a system in equilibrium? Now, concentration affects in this regard. Concentration affects in this regard that when you have a reaction in which you have something like this. For example, you are saying SO2 oxygen to give you SO3. This is sulfur oxide, oxygen, and sulfur 6 oxide. Balancing the equation, you have this. Now, in this equation, sulfur oxide, if you increase the concentration of sulfur oxide here, it then means that there will be more of the reactant. The concentration of the reactant would have been so much, and then that will make the system to move to the forward reaction. So we can say that increase in concentration of SO2, that's sulfur oxide, will lead to the reaction, the system going to the product side. It favors the right hand side. If you decrease concentration, that is, if you decrease this, that is, if you decrease this, for example, the system will not go here, it will come here. If you increase here, the system will go here. If you increase here, the system will go here. It's vice versa. Please, I'm sure that's very clear. So that's how pressure, concentration affect a system in equilibrium. I'm sure that's very clear. I'm sure that's very clear. Okay, we go to the change in pressure. A change in pressure is quite different from that of concentration. A system in equilibrium, when we talk about pressure only affects gaseous system. So it means that if you have a system like ethanol or ethanoic acid to form ethyl ethanoate with water, which we call esterification reaction, or the backward reaction called hydrolysis, such reaction cannot be affected by pressure. Or you find a reaction in which one of the reagents or one of the thing used in the reaction is in solid or liquid state. Pressure will have no effect. So pressure only affects gaseous system. I'm sure that's very clear. Okay, so let's see something now. So for example, I just gave you an example. So you have SO2 and then you have oxygen to give you this, and then you have SO3, you have this. So a case like this, for example, now you have sulfur oxide, oxygen, and sulfur 6 oxide. Having a situation like this, for example, what will happen? Now, this is 2 volume, this is 1 volume. Obviously, everything here is a gas. This is a gas, this is a gas, and this is a gas. They are all gases. So, gas. So, we mean by pressure can have effect here. And here is 2 volume. When you look at the reactant side, you are having 3 volume altogether. Here you have 2 volume. If you increase pressure, what happens? Increase in pressure favor the side with the lesser number of volume. So it means that the equilibrium will shift towards this side. If you decrease pressure, it goes towards where you have higher number of volume. I'm sure that's very simple. If you increase pressure, it goes to the side with lesser number of volume. So if you increase the pressure here, if you increase the pressure of this system, the system favors the right hand side. If you decrease, it favors the left hand side. Okay, so that's very important. Okay, that's very, very important. So you have this, 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 and you have this. I'm sure that's very clear. Okay, now how about a situation where you have equal number of volume? Does pressure has effect? A good question. No, it does not. Here now you have one volume here, you have one volume here, and you have two volume here. Does pressure has effect here? The question, the answer is no. Why? Because the number of volume at the reactant equals to the number of volume at the product. Pressure has no effect on this system in equilibrium. So that's the pressure. Now coming to the last one called temperature. Temperature. Now we cannot talk about the effect of temperature without first understanding what is called exothermic and endothermic reaction. An exothermic reaction is a reaction in which heat is lost into the surrounding. In an exothermic reaction, the reactant tend to be greater than the product. And then, so the enthalpy change is negative. What's enthalpy? The total heat content of a system. That's enthalpy. Okay, now, in an endothermic, heat is getting into the surrounding, into the system. And what happened? The product is greater than the reactant. So, for an exothermic reaction, in a case like this, like the case of ammonia that we cited, let's look at this case now. We have nitrogen, hydrogen, citing a case like this with ammonia, and then our enthalpy change is negative. Okay, our enthalpy change is negative. If the enthalpy change is negative, here we're saying that what do we do? If you increase temperature for an exothermic reaction, remember the system is losing heat, and here you are increasing temperature. If you increase temperature for an exothermic reaction, what happens? It means that the system is going to go backward. For an exothermic, please don't forget this, students. The system will go backward. But if you decrease temperature for an exothermic reaction, the system goes forward. But for an endo, the reverse is the case. Since endo, the system is gaining heat, so if you increase temperature, it goes forward. If you decrease temperature, it goes backward. Now, it should be noted carefully. We are talking about equilibrium here. We are not talking about factors that affect reaction. If we are talking about factors that affect reaction, we would have mentioned catalyst, we would have mentioned surface area, we would have mentioned light, maybe nature of reactant, which is like surface area. Okay, but now we are not mentioning all of those things because catalyst does not affect reaction in equilibrium. Catalyst can only affect the rate of attainment. Please, do you understand that? It does not affect the equilibrium reaction, but it can affect the rate of attainment. That is so important. The three factors that affect the reaction in equilibrium are change in concentration, pressure, and temperature. This is very, very important. And also, you should note this carefully and very carefully that only temperature can affect equilibrium constant. There are three factors that affect reaction in equilibrium, while only temperature affects the reaction in equilibrium constant. I want to believe you got value for this tutorial. Please, you tell your friends about it, tell your classmates about it, tell your colleagues about it. If you are a parent watching this, tell your children about it. It's not going to be a boring time with the tutorial me. I hope to have you in my next video. Do have a wonderful day. Okay. Thank you for watching the last video. In case you have any question or if there were things I said in that video and probably you're not clear with those things, kindly drop your question in the comment section. I'm going to attend to whatever question you're having in the videos on my channel, either the chemistry or the mathematics. And please don't forget to tell your friends about the channel. And like I promised you all, it's going to be a moment of scintillation. It's going to be a moment of thrilling time and all that. So please don't forget, this is your science tutor, Yomi Omorewa. God bless you for watching all